Since insulators slow down heat transfer by conduction, they are used in buildings both above and below ground, as shown by the arrows in the diagram. The cabinet on cooling coils is often insulated to prevent the casing from becoming so cold that water in the air condenses on the outside, causing sweating. The casings of furnaces are often insulated to prevent the outside from becoming so hot that it is dangerous to people or the building. For practical purposes, all materials possess heat energy. As we have already seen, this energy exists in two forms. Sensible heat is the energy of molecular motion. It can be measured by temperature and always causes a temperature change in the substance heated. For example, when a pan of water at 32 degrees Fahrenheit is placed on a stove and heated so that the temperature climbs from 32 degrees Fahrenheit to 212 degrees Fahrenheit, it is a sensible heating process. The temperature has changed, but the state has not. No boiling has occurred. Latent heat is the energy of molecular separation and arrangement. It cannot be measured with a thermometer. A latent heat change causes a change of state at a constant temperature. If the pan of water at 212 degrees Fahrenheit is further heated, it will begin to boil. As heat is added, it will continue to boil until all the water turns to steam. While it boils, the temperature stays at 212 degrees Fahrenheit. This is a latent heating process. The temperature does not change, but the state changes from a liquid into a gas. As we saw earlier, much energy will go into separating and rearranging the water molecules to make it a gas. A characteristic of a refrigerant is its ability to boil, that is, to change from a liquid to a gas at a low temperature. The total heat of a material is equal to its sensible plus its latent heat. The total heat of any material will change if either its temperature or state changes. Liquids and gases contain both sensible and latent heat. For example, the water at 32 degrees Fahrenheit contains the sensible heat needed to warm solid water, ice, to its melting point, 32 degrees Fahrenheit. It also contains the latent heat needed to melt the 32 degree Fahrenheit ice into 32 degree Fahrenheit water. Both sensible and latent heat enter spaces and become a cooling load which must be removed by refrigeration equipment in order to maintain comfort. When it is 95 degrees outdoors, heat is conducted from outdoors to indoors through the roof, ceiling, walls, windows, and doors of a house. This adds sensible heat to the indoor air, raising its temperature. Radiant heat also adds sensible heat to the air as sunlight enters the house through windows and is absorbed by things inside the house. Sensible heat is also added to the air by people, lights, and cooking. Latent heat is added by anything which turns water into vapor, cooking, for example. Even though such latent heat additions don't raise the indoor air temperature, they increase its relative humidity. The total heat entering a space is the total cooling load for that space. It contains the sensible heat, sensible cooling load, plus the latent heat, latent cooling load. Sensible heat in a warm house moves into the cold refrigerant of a cooling coil as the air flows over it. The coil is providing sensible cooling capacity as it removes sensible heat from the air, reducing the air temperature from 80 degrees Fahrenheit to 53 degrees Fahrenheit. This process also removes latent heat from the air as the water vapor in the air changes state to a liquid, condensing on the cold coil surface. This is the same thing we observe when water vapor condenses on the outside of a glass of iced tea. The air coming off the coil is not only colder, but it is also drier than when it entered, allowing it to absorb both sensible and latent heat when it enters the space. Heating coils add sensible heat to indoor air. In such cases, the coil provides heating capacity. For example, air returning from the heated space at 70 degrees Fahrenheit is heated to 95 degrees Fahrenheit as heat from the fluid inside the coil is conducted to the cooler air flowing over the coil. Latent heat transfer is the main way mechanical refrigeration systems move heat. This close-up look of a cooling coil shows how cooling of the air is accomplished. Liquid refrigerant in the indoor coil tubes boils at a fairly constant temperature. As the refrigerant flows back and forth through the coil tubes, more and more liquid refrigerant boils away until it is all gas. The latent heat required to boil this refrigerant is taken from the air into the refrigerant, thus cooling the air. This boiling process is called evaporation in the refrigeration business. The coil where evaporation takes place is called the evaporator. The latent heat transfer process happens at a low temperature because of the nature of the refrigerant and the low pressure in this part of the system. This diagram shows how latent heat transfer is used to heat the air. Refrigerant in the outdoor coil condenses from a gas into a liquid at a fairly constant temperature. As the refrigerant flows back and forth through the coil, more and more of it condenses from a gas into a liquid until it becomes completely liquid. The latent heat required to condense this gas is rejected from the refrigerant into the air, thus heating the air. In the refrigeration business, this process is called condensation. The coil where condensation takes place is called the condenser. The temperature at which condensation happens is higher than the temperature for evaporation because the pressure in the condenser is higher than it is in the evaporator. In Module 2, Temperature and Pressure, you will study the remaining foundation blocks you need to develop a basic understanding of air conditioning and refrigeration. In that module, you will obtain an understanding of temperature and pressure and how they are measured.
Now is a good time to take stock of what's been gained during your study of this module. Review the skills shown on the Student Skills Inventory sheet located at the back of this booklet. It should encourage you to see that you have many more of these skills now than when you first began this module. There probably are some areas that need additional review. Repetition is a normal part of the learning process. Why not circle those skills that need additional work and go back to review those sections once again, answering the skills check questions that apply.
At this time, stop tape and answer the skills check questions to this section in your workbook. We are committed to sharing knowledge and helping everyone improve their professional skills. If you enjoy this type of training, please like this video and subscribe to the channel. The next episode will be even more exciting, so don't miss it. You are also welcome to leave your comments or email us with the topics you are interested in. We will select the most requested topics and discuss them in future episodes.